Welcome back, PlayBASIC coders. Today's little coding adventure will look into raycasting, as you would have seen in classic games like Wolfenstein. Now this demo, I went through it before, but I'll go through it again. Here we're setting up the map. The map's just a bunch of data statements down the bottom. We set up a collision world, and then we run through the world, and each block that we see in the map, we determine if that is the bordering line or not, and then make an outline of that block in these line fragments. It's important to understand this because the next problem is going to be related to this. So that's what we have to solve. So this makes the outline. I've got some code in here for dealing with projection. We're rendering the screen, bit of a mouse button thing, and we'll just run it anyway. So I've got sort of a Wolf 3D looking scene, bit of camera. This shows you the error though. If we move the camera somewhere like that, I can move it with the mouse actually. See, when we're looking side on to this block here, why are we getting all of the same texture across that wall fragment? So internally the intersection is working. We're casting out rays from the player at very small intervals, but across into this world here, this red map here. The green represents the field of view, so that's the direction we're currently looking at. Now, if you look at this closely, when we are on the left-hand side of this, we're looking at what I would think of as being the depth of the map, right? So horizontally is the x-axis, and then into the screen is down the z-axis. But when we find the ray intersections, we're just finding the intersection point of the ray cast out from the viewer that impacts the world. That's all we get from it, a location in world space. Now, if we go back and have a look at the code, so we're stepping across the whole screen from the left-hand side to the right. And for each vertical column, we are scanning, throwing out a ray out into the world, computing that ray's intersection point. If it hits something, it may not hit something, and that's something we'll need to deal with at some later point. I did mention this before, but once we've got an intersection point, we get a distance from the camera or the player. We work out its actual on-screen height, and then here, what Scott's trying to do is compute the vertical strip of the texture that it should render in this location. Now, that's fine when you hit along the x-axis. The texture will be aligned and the x values are obviously ascending. So we run it again. If I move the camera up here, so this red line in front of us, because this line here is aligned across the x-axis, we can just grab the x component of the intersection and then find the modulus of it, and we're using that to work out to get what vertical strip of the texture we want to draw. Now that works fine as we go across this x here, because we'll get different x values for each time a ray intersects this wall here. But down here, that's not the case. If you look at this fragment here, the x across every intersection of this wall here is the same. That's why we get the same vertical fragment. So we would need to work out what side of the box, in this case, we're coming from and impacting with. And it's pretty easy to do. You can just kind of a quick guess and you get pretty much something that works pretty well. That's why it happens. All the other codes basically the same. This is the original version, so I did tweak it up a little bit. It looks like it. Right, again, you can toggle the map on and off, by the way. Camera movement's a bit smoother as well, but you'll see that problem's gone away. And it's the way all we need to do is work out what side we're hitting. If you look, notice there, put the map back there, if I move the camera back, those walls will turn to garbage. Hopefully you should have an idea of why that happens. If not, if you look at that part of the code, look at the actual intersection code down here. All the rest of this example is pretty much the same. There's a few little bits and pieces here that we need to implement. I'll sort of go over them now, I guess. So the rendering loop is the same. We're working left and right, working out we're casting a ray out into the world, or computing where the end of this ray is going to be. That's important to understand because this has a particular length. So we're calculating the end of this ray from the player's current position, doing a comparison with the world to see if there's an intersection. What happens if there's no intersection? What happens if that ray isn't long enough to hit a wall far in the distance? Well, you get garbage returned. You get nothing here returned from this loop. You just get the previous values of x2. That's what we would need to do. If we check for a ray intersection and this didn't hit something, we would need to have a longer ray until it did hit something. So generally, what I would think anyway that you would do is probably have a much smaller initial ray. This is 1,000 units long, but let's say it's like 250, the initial cast out. So in small tight corridors, those rays would hit the walls, and that would be all the work that it would need to do. As you got into larger open spaces, they might not hit the walls, and you might need to like double the magnitude and then do another comparison to see if that hits the walls, and if that doesn't hit the wall, we do it again. So it's this kind of testing approach that would solve those problems. This is the problem where the walls in the distance weren't being rendered correctly because it doesn't have there's no intersection, so there's nothing for it to actually use other than the ray's endpoint, which could be anywhere really. Nonetheless, we calculate the distance, work out the vertical size on screen, and here's what I'm sort of trying to get at really is that in our map internally we've got these line fragments that represent the outside of the block region. That, like in classic Wolfenstein, it's like one block represents a sort of section really. Here we've got lines around the outside of it, and that viewer's ray could be coming from any direction into the block. So we would need to know the impact point of the ray against the wall, because it might be the top wall, the side, etc., or the bottom. So one way to do that, kind of cheap way really. So here I'm grabbing the modulus of the impact point of the ray on the x-axis with the block width on there. So if you think of that carefully, if this x-coordinate here is perfectly on this vertical x here, in memory it's the z-axis, but here it's the y-axis, that's going to be our trigger point. So what I'm saying here is, if this happens to be 0, we'll assume this ray hit a vertical line rather than a horizontal line, and that's all we're doing. And it's because 4 lines around the outside of, or 4 possible intersections around each block. That's why we've got here, is the offset less than 0? In other words, is it on 0? Or it could be the other side of the block, which was pretty much the next block, but with a shared wall. And we've got a bit of a lossy comparison here, so we're dealing with floats. So you've got to be careful that you don't get rounding errors, or you don't get sort of things truncating, or things doing weird things. So we're just going, well, that'll do for the time being. If that's the case, if our x-coordinate happens to be on one of these, on the start or the end of the line, then we treat the y location of this impact as the offset into the texture. So we assume it's a wall running, rather than sort of left to right, it's running into the screen, or running depth-wise. If it's not that, we just do it, we use the x component, and that's it. But this is all you really need to understand is that these tiles, the ray can be coming from any direction. So if we just used this x component here, like if we just force that here, if we just always use that, for example, we should get the same look we had before. So down here, for example, these all use the same vertical strip because the x coordinate along this strip here, this wall fragment here, is not changing. They're always the same. The z's changing. That's why we're using the z component when this occurs. Get rid of that. Kind of show what I mean. I wrote another little program there somewhere. Where is it? All right, we've got a rectangle rather than a square, but here's the concept. So the line I'm controlling is a ray coming in from the viewer. Now, that ray is going to be only able to intersect faces that are facing the ray. So that's this line fragment here is showing, that the bottom one here is in play. The red line is showing that there was an impact, and the red dot is showing there was the position of that impact. Now, that's occurring in screen space. We're doing ray intersections in world space, pretty much. The same problem, you're right. Not really a problem. The thing we're trying to understand is that these intersections, that location there where that red circle is, that's on the bounding box of this volume, but it doesn't give us a strip to render. We've got to work out what side of the box and then work out what position to render from that side there. That's one of the things I did need to change. Going back to the example. One of them I have changed in here, wherever that is. You'll notice that we're getting the modulus of the coordinate in space of the intersection of this particular ray cast out from the camera. And then we're getting the modulus of the block size. Now, the block size of the map in this particular example is not the same size as the texture. They're actually different. The block size here is just kind of smooshed up a bit to fit on screen, so I could sort of see what was happening when we're trying to render this thing. So we need to scale that back to the size of the texture, which is what this ratio here is. So if we're working out which line to get on the x-axis, on the y-axis, on the z-axis it really should be, they're different. I'll show you that up here. Right, so when I'm working out the size of our map, when we're converting it from our sort of character array, which just has zeros for empty blocks and ones for solid blocks. Normally you would use that as the texture index, of what texture to grab from out of all of this, right? I'm using our map width and our world width, but I'm dividing those two things here. If you look at the screen size, it's not square. So the width of our tiles or blocks in world space are a different size than they are deep, and because of that we need to scale them appropriately. Otherwise you end up with you rendering outside of the texture or inside the texture. I'm not going to say, that's, in terms of being accurate, I wouldn't call it accurate, but it's good enough. That's where we are. Alright, one last look. Turn the map off. Sort of wander around. Yeah. Oh yeah. I don't know how many of these demos I've made over the years. I think every time I've done this it's been different. Map on again. Well, that part there shows this actual thing in play. In other words, this portion of the screen over here, where our rays are passing through, they're just not finding an impact against the environment, and then has nothing to render. Runs pretty well. Yeah, whatever. Alrighty, that'll do us. It's pretty late. We'll get some sleep at some point. Thanks for watching, and I'll see you next time. Bye.